Right. So imagine that you're a data engineer and you build data pipelines as part of your company product. Now, this is a data product that serves many of the customers. It basically, you're creating data insights for your customers. And the architecture involves running Apache Spark, some Delta Lake, some Airflow, and you're working with petabytes of data, and every record matters. And one day you're tasked with replacing one of the logic components of a legacy data pipeline. I hope it sounds like fun. You don't know the code base that well, and deadline approaches. There's a testing system in place, but it doesn't cover all the edge cases or specific issues that comes with the various data volume or velocity or variety. The testing system is really minimal and should guide you around the existing system while you develop the code changes. So you develop the code changes, you test them in staging, you push to production, and you hope for the best because YOLO. There's no better solution, and the only reliable place to test your logic is in production. So when customer calls in a few days later asking to clarify their dashboard behavior, you're not surprised. Does that sound familiar? Let me know in the chat. So my name is Adi, like Justin just said. I'm a data engineer by trade, and I'm executive at Reverse, which is focusing on developing industry best practices for working with data systems and building data platforms. And during my decade of working with data, I was exposed to many challenges and frustrations, such as the one I just described. And I always had challenges as an engineer working full-time, like how can I test my environment end to end? How can I really know that I'm covering all the bases that's related to the pipeline? And I always curious, like, how is that we still allow testing data pipelines in production without introducing different layers of protection? How is that, so much records are at stake because we're selling data insights. We never took the time to embed different practices and standards that allow us to handle scalable data. This is also a big topic that we have in the data engineering Slack community. And today, this is what I want to talk about. It's like, how can we develop these pipelines, work with legacy code, and really install more confidence to protect our production systems from these unexpected scenarios. And you're probably curious of how our unexpected these scenarios are. So I recently listened to a great session by Holden Caro, and she said that we cannot expect Spark to just work. So there are multiple hidden behaviors that can result in data inconsistency. And these hidden behaviors usually arise from the different optimization that we're doing to run this distributed computation on the data. For example, Spark 3.0 introduced adaptive query execution with the goal of speeding up Spark SQL during runtime. And as you can imagine, that means there's a lot of dynamic optimization taking place within the operations, the DUG that Spark runs. So there's dynamic coalescing shuffle partition that takes place. So for every operation, actually, the catalyst will go in and see if they need to run another coalesce and shuffle partition. There is a dynamically switching between join strategies. What usually happens, the catalyst, the Spark engine optimizer will decide on the join before, but here with the new adaptive query execution, it might be that with every operation that we do on top of the data, the catalyst will decide to switch the join strategies. And lastly is dynamically optimizing skew joins. If it notices some specific skew joins, it will try to automatically, dynamically optimize it. So you can imagine how all this automatic procedures, reoptimization procedures that happens with every iteration on top of the data can introduce a lot of challenges and pain. So at a high level, for everyone here that wants a reminder of what a complex, relatively complex data flow is, that means that we have multiple data sources that we read from, and then we're operating using filter, join, select, all of these functionalities either with code or using SQL language in order to extract insights and really develop the dashboards or the BI or make decisions on top of the data. So here, for example, we have kind of a more traditional business funnel. So there is data that we're capturing from sales, data that we're capturing from marketing, leads, etc. And then we do some extrapolations on top of the data in order to present it in a BI dashboard for the business. So what can go wrong with data flows? So just like I mentioned in the beginning, it might be that I have legacy code and I would like to introduce new logic. I want to replace only one piece of the whole pipeline that I have. So that might introduce friction, that might introduce issues into the system with all the connecting tissues. I might want to introduce new data source. I want to be able to enrich the data that I already have in my data lake. And so I want to bring in another data source and then run extrapolation and somehow merge that data into the rest of the data stream that I have. It might be that during these processes, I will introduce incompatible schema changes. We always see it as the main thing is like, we want to have new component logic, new data source. How can we make sure to introduce the right schema change and populate it through the rest of the pipeline? It can also be that my schema evolves with time because this is how the logic is built. Another section is, it might be that Spark jobs ran twice. And this happens when we want to manually sometimes tweak a job that didn't run or a job that failed, or something happened with our flow manager and for some reason, or it ran twice in parallel and produced duplicated data. Or somehow there was kind of a other issue that arose from the fact that the Spark job ran twice. It might be that we want to change table relationships because of now we're changing the logic, we're changing the data, we want to change the relationships and we want to change the keys specifically there. So more problems because we're data engineers and we have a lot of them. We accidentally deleted yesterday events partition. There was erroneous data record and we decided to go in and try and assess where the problem is, and we actually deleted the whole partition in production. And that happens all the time. And this is because usually we are already in the mindset of YOLO with everything related to testing. And this is a great tweet that was posted earlier this month, but Matt Ryer, that if you're familiar with the culture of disagree and commit, Matt here actually said, I'm disagreeing with the testing because I cannot trust my testing environment. And so I commit the code anyway. So now that we know that sometimes it's related to culture, sometimes it's related to systems, sometimes even the tools, the distributed compute tools that we are using, introduce different optimizations during runtime. We want to be able to predict it and kind of lower the risk. So specifically, chaos engineering speaks about the discipline of experimenting on software system in production in order to build confidence in the system capability to withstand turbulent and unexpected conditions. So we can take it to our world and say, in the data engineering world, how can we experiment with large complex data flows in a way that allows us to test in production and minimize the impact of error. And I always like to think about the different principles that chaos engineering brings to the table for distributed systems, and then see how they are equivalent to what we do, to what we're facing as data engineers. So this is what we're going to talk about. It's like, how can we see the equivalence and what are the things that we can do in some of the use cases related to them. So when we are practicing chaos engineering, we want to be able to generally experiment as much as we can and experiment in production. So the first thing that we want to do is define the steady states. And steady state means this is like our optimal solution. This is defining the what and not the how. For example, because it comes from the DevOps and SRE world, it will be the system throughput, error rate, latency, percentiles, etc. It's not about how do I create a highly available system. It's more about I need a highly available system with so-and-so latency percentiles. And the equivalent for us would be the data product requirements, because we're as data engineers, we're producing data products that our consumers, our data customers are using. And so we want to be able to define these requirements and have these requirements as the what and not the how we're reaching them. So an example for some data product requirements that we see is, for example, accuracy. And accuracy can be defined by asking ourselves, like, are customers looking for data, or they want to get the whole analytics dashboard and so they can drill down into all the data points, or do they only want the insights, the top level, and the extrapolations on top of the data? Another question that we can ask ourselves is, does the user trust the data? Does my data consumer believes that this data is accurate? Because if it's not, it's probably not going to either buy the product or make actions based on it. So this is kind of a high level guidance of how we think about the steady state and how we can define data product requirements. The second principle speaks about acknowledging the variance of real world events, knowing that there is a steady state, knowing that we're aiming to reach that steady state with every step that we do as an engineers. We should acknowledge that no matter what happens, there's always going to be great variance from our staging environment or our development environment to what really happens in real world. And so in the classic DevOps, it speaks about hardware failures like server dyings, spike in traffic, and other fun things tenants can do. In the data engineering space, we speak about schema changes, corrupted data records, data variance. If we now get a completely new data that we never processed before in edge case, or somehow we accidentally deleted the yesterday events partition. So this is the different variety that is available for us in the world, like kind of the experiment that we have to work with, the steady state, and then the issues that might occur that happens in real world. The third principle of chaos engineering speaks about running experiment in production. And the reason it emphasizes on running experiment in productions is to guarantee both authenticity of the way in which the system is exercised and the relevance to the current deployment system, because we're speaking of the infrastructure. So chaos strongly prefers to experiment directly on production traffic. And the equivalent for that for us is experiment directly on production data. And the goal with running these experiments is to discover weaknesses. We want to be able to discover weaknesses and address them in time before these weaknesses are being discovered by our customers. And we want to make sure we're doing it in a control environment. So we actually are we're operating and making sure we have enough people in order to withstand that turbulent that might occur now in production. So this is a big step of what chaos engineering is. It's like running experiment in production. And so same principle applies to data. However, if we are selling data, if we are selling insights, that means that if we lose all the data, we're going to be in a big problem. And so we have to be able to build an experimental environment on production data inside production in a way that is sustainable and healthy. And what most of us are doing, so I've seen some customers were already practicing it, and also in the community, some people practice it, is specifically on object stores. If I'm looking at S3, I have the concept of buckets. So I can say, I have all my data here. This is kind of my main data that I'm working with, and I'm going to copy it into a bucket, a different bucket in production. And I'm going to label it and give it the name of experiment 1. And then I'm going to do another copy, and that will be my experiment 2. And then we'll run some diffs between them in order to understand which experiment went well, which code did well, so I can later on use the same approach directly on my data. So that means often a lot of manual work. So for example, if I have 32 tables and I just gave a number, that means that I'm going to copy 32 tables into a new bucket, going to do deep copy, experiment on them, and then hope to merge back what came out of them. And usually because of human error and because we're doing a lot of that work manually, that would mean that I would probably merge 30 of the tables correctly and miss on 2. And this is just statistics. Another aspect of that is if we're looking at object stores, specifically S3 or Azure Blob or GCP, is it is relatively cost efficient, but it's not free. And so we might have a higher, we're going to have a higher check at the end of the day, around 30 to 40% more, just because we're doing this deep copy on top of petabyte of data, which is also going to take us a long time to do. But it is necessary in order to have that experimental environment on production data inside production. So this is kind of a high level of how we would go about it. We'll create another repo, another bucket, and then we'll use the dedicated URL in order to reach it. The fourth principle speaks about automating these experiments to run continuously while minimizing blast radius. In the classic DevOps SRE world, we use what's called chaos monkeys, and chaos monkeys runs on top of my production and will kind of cut the wire in between different machines or kill some of my pods or really tweak my world. So to check and test how steady and how stable my production environment is, with the goal to discover the weaknesses so we can solve them. And that really goes back to some of the culture aspect that speaks of, I'm not defining how to do it. Remember back in the beginning with the steady state, I'm not defining how I'm going to go about that, but I'm defining what I want to achieve. And so this is a great way to discover weaknesses, because it doesn't run any extrapolations based on how the system was developed. It only looks at what exists and now taking off machines or cutting the wire for the specific network, going to show me how the system can withstand that specific turbulence in the DevOps world. In the data engineering world, this is a bit more complicated. And here we want to introduce different stages. So similar to what we spoke about before with buckets and having kind of a main bucket and then experiment 1 and experiment 2, we want to be able to introduce that kind of data lifecycle inside stages. And the goal here is to install confidence in the data early on, so we have a controlled environment. So our whole data stages that we're now introducing is a controlled environment where we're running our experiments and we run it continuously in an automated manner. And so we can leverage that to minimize the blast radius of introducing erroneous data, for example. So I laid out the stages, and I like to, if we had experiment 1, experiment 2, I really like to build it in a way that, this one bucket is development. So this is my whole stage. So development stage inside my production, on top of my production data, will enable me to run these experimentation, debug my code, and also collaborate with my peers. Second thing is I want to be able to have a second stage of deployment. I'm happy with the results. I want to be able to later on deploy it into kind of my production stage, where my production stage serves my customers at the end of the day. So I want to be able to introduce some version control and introduce some best practices that relates to data quality and really qualifying the stable state that I promise to deliver on for my customers before I am introducing and propagating that data into production. And later on in my last stage is I have my data in production. It might be that something's still going to happen. Like I will run delete on top of the data on some sort. I manually enter the system. There's some script that goes and delete the data every 30 days or something like that. There's some troubleshooting I need to do. So I always have my production stage. I want to be able to act on top of my production stage. And so if there is an unsteady state, I want to be able to roll back to a steady state so I can continue to serve my data customers while taking the time to troubleshoot the problem. So my question here is, how can we automate data stages propagations in production? So like we spoke about before, we have the development, right? So I have kind of a bucket for development, then I'm running some deployment operations on top of it, and then I have my bucket for production. And what I'm offering today is actually thinking through the lens of what SREs and DevOps people are doing, and then introducing CI/CD for data. So CI/CD speaks about continuous integration, continuous deployment. And that means there are testing in between the different environment for deploying new software, basically, new code that we just developed. So the same thing. So the same thing we can do, we can leverage and actually do it with our data. So we can manage moving in between data stages and data propagations the same way we manage our code. So for example, if I'm looking at my GitHub or any other GitLab, for example, I would have my main branch where I'm working on directly, and then I will create a dedicated, I will branch out, create some changes on top of that branch, and then decide if I want to merge that code back into my main branch. So similar approach, only with my buckets, with my data buckets. I'm able to branch out of my main bucket into my experimental bucket, run some extrapolations, and then merge it back. And ideally, I will be able to merge it back automatically using a dedicated script. So for example, a dedicated webhook that enables me to run quality checks on top of my data to make sure I can expose it to my data customers. And so that brings me to an open source I've been working on. This is LakeFS, and LakeFS provide exactly this capability. So it provides us the ability to run Git for data. So the same way we use GitHub for CI/CD with version control, we can leverage for working among this different data buckets that we have in production. So we can actually version our data that's available in production. It's not a Git one-to-one, and this is always a confusion because Git is for humans, for us, for engineers, and it doesn't scale for petabytes of data. And so LakeFS introduced this approach where it's not for human, it's actually for machines. And hopefully this terminology makes sense. So for example, if you find that you need to recover from an error, like we saw in the production stage, it might be that accidentally we introduced some error into the system, we wanted to roll back, we wanted to revert, so we want to go back to a steady state. This is what Git gives me also as a source control. If I want to create a dedicated experimentation environment, LakeFS gives me the ability to actually develop in production, so I can create that branch. And what's nice about LakeFS versus the other way that we do it manually is it's relatively close to zero copy mechanism, because under the hood, it uses something called Merkle tree. And this is a cryptography tree that enables us just to track the difference of what happened to the data without actually holding a deep copy of all the data. So this enables me to develop what I just mentioned in isolation. The third one is troubleshoot. Let's say I did have some issue. I want to first revert so I can expose good data to my customers, but I do want to continue troubleshooting what happened in the system because I want to be able to make sure I'm eliminating that weakness for the future. I don't want to wake up in the middle of the night knowing that something happened, so I want to be able to troubleshoot it. But I want to be able to troubleshoot it in a calm way, not because customers are pushing me, because I already did the revert and gave them back the steady state. And now I can, during my work hours, really go back and troubleshoot and look at the dedicated commit where the data got corrupted and understand which logic ran it, what came before, what was after it, and see the results. The fourth bullet point is atomic updates. Because how LakeFS works, I am able to atomically merge all the changes that I did from my experiment branch, from my experiment bucket back into my main bucket where I'm exposing it into production, and that using the merge capability similar to Git. And the last one is reprocess, or better yet, reproducibility. So for example, if we need to do some backfill or any general reprocess of the data later on, then we can create a new branch, run, assuming we got new data into our system, into an object storage, run the same computation, and then merge it back into the logic. And this happens a lot, especially with late data, that we have to do that backfill in order to propagate that data back into my analytics BI or my customers. And I mentioned that LakeFS doesn't do the deep copy like we talked about before. And it's because under the hood, it uses the mechanism of the Merkle tree, which gives us the capability only to look at the specific merge, the specific commit. And so when I'm introducing changes or when I'm reading later on changes, it's going to look at what's already available. And if I introduced a new change into the data, then this is when it's going to write the record, only after I'm writing it directly.
Quick question for you. As a developer, we got more questions coming in too. So if you want, we can hang on some more. As a developer, is there like a easy built-in way or easy way to see what actually is different now between my main, or whatever you would call it, my main and my branch that I'm working with? That sounds pretty difficult to implement. So I'm curious, like how much of that done for you versus, I don't know, how you would do that, I guess, is the question.
Yeah, so specifically LakeFS, because it uses the cryptography tree, you can look at the files that got changed. But if it's a Parquet file and you want to look at it from a human eyes, that you'll have to use some way to read Parquet back. So definitely, yes, you can do it. However, it really depends on the specific file formats that you're using. However, you can do it programmatically. So for example, if I have multiple branches, I can say, okay, I wanna read from, in my code, I wanna read from my main branch, and then I wanna read from my experimental branch, and then I wanna do this diff programmatically and somehow present that diff in a way, or run extra logic on that diff to make sure it actually works. And because we're working with large scale of data, we need to be cautious of how we're presenting that diff, right? I don't want to print it to my log and explode it, right? Or maybe I want to save it in another area so I can do more extrapolations on top of it if I want to, or kind of deep dive into specific records. But the goal here, because we're working with big data, is always to do it programmatically and agree on what we want to see there. So what are the expectations, like the what, not the how. So what are the requirements for my data product in order to decide if that makes sense and I want to merge it. So it very much depends on the business logic at that point. So what I usually recommend, it's because it's always a bit harder to understand how these is going to look like, is try it out on a small scale. Like take very small chunk of the data so you can actually be able to see what happens in the system with your own eyes. start small and then automate and then run it on the bigger data pipelines that you have. I hope that helps.
Yeah, that makes sense. Would you like me to read out a few of the chat questions to you now?
Yes, would love to.
So we got from Adam 2 questions. The first was how do we make sure that LakeFS keeps the data integrity when merging back to main?
So there are different data strategies, and that really depends on the data format that you're using under the hood. So I recommend reading into the data strategies. For example, if you're using, so there are special data merging strategies as well. For example, if you're using it with the table format, then LakeFS would leverage what is available for merging in a data format. For example, Delta Lake hold the logs of all the operations that took over the data. And so LakeFS will leverage what's already available from Delta Lake in order to provide you, in order to put an order into how to merge the data back. So there's like the traditional way of how LakeFS does it. And then there's another extra special merge that depends on the data formats that you're working with.
And then the other question from Adam is it used for static data only or for all data?
So it's format agnostic. So all data that is binary, which is everything.
Cool. Yeah. And then Tammy's asking, does LakeFS version just the data or the metadata like schemas and processing pipeline code as well?
So only the data, it acts only on the binary files that we have, and it does captures some metadata on top of the data, like which files got changed specifically. Because it's schema agnostic, it doesn't capture a specific change. It won't tell you, hey, you just added another column here, or there was malformed type that you introduced into the system, but it will tell you which files got changed, when, and by whom, and hash difference between the files, so you can later go and investigate it. It doesn't keep the source control changes. So for that, we have Git, and this is separate because my Git usually run in one environment, and then my production, my data probably in the cloud or on premise, but it's a completely different environment where I'm actually leveraging deploying of source control into my, let's say, cloud. So these are different systems.
Okay, and what is right now the last question we have in chat is just kind of confirming. So just to make sure when the merge happens back to main, there would be no duplicate and we would only see the updated record. Is my understanding correct?
Correct, yes.
I think they're just trying to believe it. So cool. Thank you for,
give it a try.
Let you keep on going here. Thanks so much.
Thank you so much. Hey, give it a try. Keep me honest. If there are any issues, it's an open source. We're here to solve them. I believe this is one of the greatest powers of community. It's like the ability to flag out different things that doesn't work well, or things that do work well, and kind of give kudos to a lot of contributors and engineers who's been putting a lot of hours into it. So yeah. Cool. So what does a typical environment looks like? Like we mentioned before, we have the different branching. And so we can have the main branch, and then we can have dirty ingest branch that wants to introduce some malloc records into our system. And so before we're exposing it, we can run this webhooks that you can see here on the merge operation to make an automatic decision, similar to how we work with CI/CD, to decide if we do want to merge it into the main branch and propagate and expose it to our data customers. So these pre-merge hooks help us run all the quality checks that we need. Later on, we can also branch out of them again if we need to. And one of the greatest use cases that I notice time and time again is reprocessing or reproducing of specific data. So like I mentioned before, if I have backfilling log, if I have backfilling or I need to undo some previous filters, sometimes it happens that my customer will want to see specific data. However, that data is being filtered along the way, and I want to be able to go back, undo that filter, and expose them a different fresh version of the data without this specific filter. So like FS branching enables me to do that as well by running the pipeline again on a previous version of the data or a newer version of the data that was just backfilled. So kind of running this new logic, let's say without the filter in parallel to the production process that takes place kind of in the main branch. And then once we process that history data on the new logic, we can decide if we want to leverage that and use that data as a new input for our data customers or not. So we can decide if we want to deploy it, just like you see here in the pipeline, you can see a little small arrow going into deployment, or we want to delete it, right? We want to drop the existing data from the main and then overwrite it with data that we generated from the new logic, or vice versa, depends on our testing. So from this point, we can run the improved code directly on the main branch once we are happy with the results. So this is another use case that we can take advantage of.
Do you do that by like having a modified add date and using that to do the delete, or are you kind of rolling main back, reverting main to where you split and then putting in those changes?
Yeah, so it depends on what I want to achieve. Specifically like FS under the hood, but it uses a Merkle tree, which is a hashing tree for cryptography hashing tree. So it keeps track of what changed basically in the data. So if I want to roll back, reprocess, introduce new logic, like reprocess with a new logic over the data, then it enables me to roll back to a previous version, introduce deploy code, run that code separately on an isolated environment on the data that I want, and then decide if I want to merge it back. So it's kind of a combination of deploying new code that does the work, and deploying that code specifically to run on a separated branch, and then using the hooks in order to decide if I want to merge it back into my main, and then combining it with deploying the new code and the new logic to continue operating in that manner. Does that make sense?
Yeah, thank you.
Okay, so just taking into consideration that now this data is actually replacing the old data with the improved version. So now the data that is exposed to me under the main branch comes from the new code that I developed. It's kind of a more complex scenario where I'm combining both changes in my code and that creates different data. All right, so what did we learn today? We learned a lot about some of the challenges and the pain points that we have as data engineers and a lot of the manual work that we do with copying data. We understand that sometimes we can borrow different concepts from the SRE and the DevOps world, such as chaos engineering, and really bring it back to the world of data in order to create healthier, better processes and best practices to work with data. And we also realized that as long as we're using the branching mechanism, it's okay to make mistakes, because we can always roll back to a previous version of the data, previous version of the whole repository if we wish to, and kind of leverage this mechanism as a protecting layer for us to run experiments on data in production. So we have a great Slack channel community, and we also have the open source on GitHub. So we would love for more contributors and people that want to try it out and let us know how we can improve it. And also, if you like it, if you find it useful, give us a star. We always appreciate it. It also shows that more and more people are interested in LikeFS.
Really cool. Any particular types of contributions that might be a good starting point, or is it best just go check out like the issues on GitHub or jump in the Slack channel, or what?
So we have, like every project, like every open source project, we have kind of a tag that speaks about, best to start with, good tasks to start with. So if you want to go and jump on that, go ahead. We're also looking for people who wants to help us improve the documentation. So for example, if you are going through LikeFS and there's a couple of challenges you don't fully understand, what does that mean or how to use it, you're most welcome to join our Slack, and we can do like a quick brainstorm and think through, what is the real use cases here, what are the friction, and then we can go ahead and improve the documentation together so more people can benefit of it. Out of it. Specifically, LikeFS, the internals itself is developed in Go. However, there's a big integrations with all the data ecosystem, and these integrations would usually be in Scala or Java, because this is or Python, the more dominant programming languages. So if you're comfortable with Python, Scala, Java, then we have a bunch of integrations that we want to implement, and we think will help people to take advantage of LikeFS in different constellation and different data stacks. So would love that as well. Yeah, and just going in and giving a star is already a good start.
Cool. Yeah, we had the comment of have to give it a try. Hope the tutorials are good. So now you can you can make the tutorials better, make the documentation better by contributing if you want.
Always. You can always make it better. I don't know. Do we have a couple more minutes? I would like to show you. Okay.
Yeah, we have some time. That's kind of what I was wondering, is if you wanted to do more. Yeah, we got, we can go till 7. We can go another 40 minutes, but I'd say at least a good 10 to 15 minutes people will probably stick around for. No problem.
Perfect. Okay, so I have, let me just share my screen again. Okay. So I wanted to show you how the LikeFS UI looks like. It's very much similar to GitHub. And this is because many of us believe that it would be a good idea to bring in a concept that is familiar to all of you and kind of leverage the way GitHub is structured with repositories. So inside of it, you can see that I already created multiple repositories, and each repository can have multiple tables in it or any type of data that I want to have in it. So for example, under my BI reports, I can see I have tables, and under tables, I actually have 4 different tables that are available for me under the BI report. Specifically, you can see here Snappy and Parquet, and because this is a Delta table, you can see the Delta log inside as well. Going back to my repository, I want to show you actually the AWS demo. So here I have some data that I brought in, some raw data that's shows different products by rating, and also raw data that is available here in Delta log as well. And let's say I want to start experimenting with it, right? I already said as data engineer, I want to experiment with data. I want to be able to experiment on in production. What I usually do, I will go ahead and create another bucket on S3 or deep copy of the whole data in order to run my experiment. But actually here, I don't want to deep copy. I want to save some costs. I can leverage LikeFS in order to create a new branch. So I can go into branches and create a new branch and just give it a name and call it a D for a second. So now you can see I have this new branch, but this new branch is actually the reference commit. You can see the reference commit is identical to the reference commit of the main. And this is because LikeFS does it has a leverage to zero copy mechanism, where it actually looks at what changes in the commit. So the commit will change once the data will change. So you can see here, it's actually a similar commit. And I can go to my Databricks environment for a second, because it gives me my managed Spark, and read the data from from my Lake So here specifically, I have AWS Demo. This is the name of the repository. Temp1 is one of the branches. So if I'm looking here, I have my Temp1 as a branch, but you know what? I want to read from a D. I don't want to read from Temp1. I want to read from what I just created. So I'm going to change it here. And then I can run this Spark SQL query and see the data that's available for me in a D, and that comes from, we know we didn't introduce any changes, so it's similar to what's happening in main. Later on, I can read by rating, the data by rating, so I can also go into a D, change the branch, and read it directly from here. And now I want to modify the data. I want to actually delete the data. Once some of my logic goes over all the ratings and decide to filter the data on a specific case, because this is what my product introduced. So I can change it here to my branch again and go ahead and delete that data. So it's going to run that command. And now we realize that we want to modify the material view as well. So here we ran delete on the row table, but we want to change that by rating as well. So I'm going to go here and do this and change it on my experimental branch. So we'll give it a second, let it run, and I want to run quality checks, right? Like we mentioned before, we want to know what got changed. We don't want to specifically go into the data and see everything, but we want to see kind of a high level of what got changed inside my data. So I can run some quality changes here, and I can see that I have interesting distributions for rating. I have like 10% of my data as what rate of 3, 20% is rate of 20, 70% as rate of 5. I can decide based on my data product requirements if that makes sense or not. If I introduce some garbage, if it wouldn't make sense for my customer completely. So I can always go back and change it. But just a second before I'm doing it, I can take another look on by rating again, specifically for the different table. So please remember we had 10, 20, and 70%. Let's say I'm not happy with it. I want to revert back. I can always go into my branches and look at the uncommitted changes. And here inside, we had a good conversation specifically about the metadata, and you can see we did introduce some changes. So this were the things that were added during my run. And during my row, these were the changes as well. So I can revert specific file by file basis, or I can try and see what got changed specifically. So it told me this file added 2 megabyte in size. So I get kind of a very raw information, very metadata information on what got changed. So let's say I don't want to revert specific file. I want to revert everything that I did. So I can go here and click revert, and then I'm going to revert the whole repository. So everything I did on both tables is going to be reverted back. So nothing has happened, and I can go back and work on my data. So thinking through it is actually, I never filter it, right? So if I run it here, I should see data that's a little bit different. And here you can see, because I did the revert, because I am now looking at the data before the filter took place, I'm getting more ratings, the ratings that I didn't see before. Similar thing is going to happen here, because here it's only 4 and 5. Because I reverted, now I have access to all the data. I can introduce no new logic and kind of run this new logic on top of the data that's available here. Later on, I can decide if I want to commit my changes, but now you can see there are no changes because I reverted. But if I wouldn't, then I could have commit these changes and later on propagate them into my main branch. So going back to branches, I can decide if I want to continue working with it. Here I know, okay, I ran some logic, I tried some things, I don't need this anymore, deleting it. I can go back here and update it to the temp one that was available there and continue operating on a different branch as well. Yeah, I'll pause for questions.
So you don't have to go deep on this, but curious if there's a quick answer. Does the delta log, is the delta log like shared amongst the branches and then it gets, yeah, is the delta log shared amongst the branches or does it somehow get split off and then merged when you commit?
So because like if it operates on binary file, it doesn't look specifically on the delta log. So it doesn't care. It looks at it as binary, like everything that is available within the repositories, the different repositories, it treats as binary. So it wouldn't care, but you can still look at the changes from a metadata point of view. So if I'm running different operations, so let's go back. Let's go back into temp one and run. Oops, I have to change it back. Okay, I think we're good. And run all my operations, and we'll give it a couple of seconds to finish. Let's see. Okay, delete is by rate. Okay. So I can see that there were some changes that took place on my temp branch. I can look at uncommitted changes here. Right, so something did happen. But since LakeFS works on binary, it wouldn't tell you what got changed inside the schema because it doesn't look specifically on the schema. It will give you the size because this is what it looks at. However, if you want to, you can always, work on leverage that and leverage Spark in order to read that file and understand what happened there and extrapolate. But because LakeFS enables that versioning on top of the whole repository, it won't look specifically into what got changed in the table, but this is something that we can do programmatically and then programmatically make decisions if we want to propagate that specific data into the main branch.
Okay.
I hope that makes sense.
I think so. Quick note is that I last time, a few months back, we had someone talk about LakeFS. I think there's a lot of questions like, so when do I need this? How do I use this? And I'm realizing that this week we've got an issue with some data in production. It has stuff needed to be deleted and wasn't, or duplicates or something like that, right? I was like, oh, it's so hard to recreate that in any other environment. It'd be really nice to branch off and test out the fixes and make sure that it looks good and then merge it back in already fixed, or at least be able to test it and run that straight against production without having to like copy data into other environments or try to mimic it and then fix it there. So yeah, it's hitting a little closer to home this time for me. We have a question from Ravi in the chat, which is, can I relate this to data staging layer in traditional on-prem structure?
Interesting, data staging layers. If you can say a couple of words on it, I'd love to.
Ravi, you up for unmuting and sharing a little bit or typing in chat a little more? I know for me, the staging layer is usually like kind of the back end where I drop and recreate things before I load to the final tables. But this is a little different in that.
Yeah, that's exactly what I was thinking about, Dustin. You got it. I mean, like in the traditional on-prem structure, I believe there are staging layers, right? Where they do the manipulations and then they push it to production, I guess, right?
Oh, like if you had a whole staging environment rather than,
yeah, I mean, you can, but One of the problems with staging environment is the size of the data that we're operating on and the freshness of the data. That means we constantly need to stream data from production into our staging environment, which can also introduce PII or other security problems because we don't want to copy production data specifically to our staging environment. And so LakeFS enables us to have kind of staging environment or experimental environment inside our production systems in an isolated way without copying the data. And it's also relevant to working on-prem because it supports MinIO. And so you can leverage MinIO in order to connect LakeFS to your on-prem data repository, Hadoop, or depends on HDFS, depends on what you're running. And so have that environment in there as well, and also collaborate with other team members on the same data. I hope that helps.
Yeah, got it. Thank you so much.
Absolutely. Thank you for your question.
Any other questions out there? Either throw it in chat right now or unmute and ask it.
I have a question that might be kind of dumb, but yeah, we use Databricks at our company, and we use the Delta tables a lot. Does using LakeFS remove any functionality or benefits of us using Delta Lake, like time traveling, etc.?
So these two are actually super powerful together because they are complementary, because LakeFS operates on a repository level, so you can do data versioning on multiple tables. So a good example is what we've seen here when we have actually two different tables, and I want to do Delta Lake, they call it time travel. Here we call it rollback, but time travel on both of the tables and the same time using the same commit. And I don't want to keep track of exactly timestamp or exactly version and then do it manually, then I can leverage them together. So it actually gives me a more powerful experimental environment, more powerful data environment, because I can travel, I can do time travel on a table basis using Delta Lake, and then I can travel over the whole repository using LakeFS. So I see it more of a complementary. If I need to do troubleshooting, I might want to time travel on one table. I might want to time travel over a set of tables. Usually I would have more than one table that I'm using to develop my data products. And so it would be easier for me to go back in time where all the over all the tables and extrapolate what happened there, especially if there's operations that like join or enrichment that takes place in between these tables. And so once I go back to that specific timestamp over all the tables, I can really get into the nitty-gritty of specific table, specific record that got changed. And so this is why I see them work together really nicely, because they give different capabilities on working with data. Does that make sense?
I would think with something like Optimize, you probably would do that on your main branch and just try not to keep branches around forever so that you actually take advantage of removing files. Any thoughts on that?
Yeah, wouldn't you do the Optimize on, you run the Optimize on your main data and that gets registered as a change on LakeFS? And then you just create a new branch off of that data if you do changes.
Yeah, the goal is not to hold branches forever. The goal is to automate the process. Like I mentioned with webhooks, we want to run the experiment, but we also want to automate these experiments in order to propagate the data into our main branch so our consumers can consume it. And so what we want to do is actually delete the branches that we said, okay, we experiment with that specific data stream, we experiment with that specific new logic, or we just do it as a best practice so we can introduce these data quality or data guarantees gates because LakeFS gives us this capability. And now after we introduce it, we can go back and delete that specific branch until we need it again. So 100%. I wouldn't recommend keeping branches forever. Like I wouldn't recommend maintaining buckets of data forever just for the sake of having them, because pretty fast data becomes stale. And we want to be able to introduce fresh data that is really relevant to what's happening now in the system.
So you would merge into main and then run the optimization after merging into. You wouldn't run optimization on the branch data.
Yes, unless I have a unique case where I need to keep that branch always up. Yeah, then I'll delete it, and then I'll create a new branch programmatically when I need to, and propagate the data into my main branch following what I just said.
Thank you.
So I'm going to ask a question that to me is aligned with what Jesus was asking about. I could be wrong, but it's probably identical to what I said the last time we talked to someone from Treeverse. Is for like hourly, nightly ETL, would I be running that against the main branch typically, or spinning up a branch, running it, and then merging it when it's done?
So what I recommend is spinning up, let's say I have a nightly ETL, spinning up a branch for this specific ETL. Once we're happy with the result, merging it back into main and deleting the branch.
One of the cool things about that is I think it would give you the kind of even stronger push than you already should have to do some quality, have automated quality checks on it before you commit it and move on with your ETL processing, which we talk about a lot now with Great Expectations being talked about so much. And yet I still don't do it a lot. I'm not sure about other people, but when it comes to getting to production in time for the business to get their value, sometimes we have to speed along. But this makes, I think, even a little cleaner. Just say, if it's not good, throw it away or keep it to the side and alert people to figure out what's going on with our data. So that's cool.
It's also helped us with separating code, right? Because if we have this webhooks that enables us quality guarantees, then we can separate it from the actual code of the logic of the pipeline, right? Sometimes we would introduce kind of testing within the ETL logic to make sure that it works well, but we can actually separate them and introduce more testing as we need to without changing the logic of the ETL specifically because of the webhooks.
Yeah, the other thing I thought about during your presentation, Adi, was even if you can't get to the automation part, the chaos monkey part of it, thinking through those points that you made, and even doing it manually, like doing that type of testing against production, against your environments, is probably a much better step than many of us take. So I was just kind of in my mind, I was like, it'd be a tough sell sometimes to get the automated piece that's actually going to really give you that confidence long term. But even the concepts without that, I think, would be a good start, my opinion.
Yeah, for sure. I agree. It's we're starting small.
All right. Well, I think we've hit a good time to wrap then. Do you have any final thoughts or anything else you wanted to share before we go, Adi?
I hope we will develop better practices as data engineers. I see it always in my community in the Slack. It's like there are always these conversations on what is data strategy and how should we work with data. And I feel like a lot of data engineers are suffering because it's not written anywhere, and it's a lot of knowledge that people kind of sometimes accumulate, but they don't really agree, and everyone thinks other companies has a better data architecture, and we all realize we're kind of in the same mud of lack of available good practices. And I would love for people to chime in and really share what worked for them. I feel like as a community, this is, our best way to develop these practices by sharing what worked for us, knowing that it's true that data in every company is different, the scale is different, but often the challenges that we're facing are pretty generic. Like I've seen a lot of people manually copying their data again and again. I manually copied my data sometimes because I needed to. So, you know, being upfront about it and saying, yes, this is what we do, even if it's not the best way to do it, can really help other people joining, you know, joining our ecosystem and joining our community. So we can actually think through what is a good way to do it.
Yeah, some wise words there. Thank you so much. So, all right, well, that's a wrap for this month. Thanks again for sharing, and we'll see everyone the third Wednesday of July. And I'll try and post pretty soon about what that presentation is once I confirm with the speaker. So, thanks a lot. Y'all have a good night.
Thank you so much, Dustin. It was really lovely to see you all. Thank you for great questions.